In the complex analysis, according to our syllabus, our last point is residue theorem. There are Lorentz series and everything is there. I just take the examples on residue theorem. So what is it first? If f of z is analytic at all points inside and on a simple closed curve C. So inside this closed curve and the boundary, if f of z is analytic except at finite number of singular points within C, then integration over a closed curve C f of z dz is equal to 2 pi I r1 plus r2 plus r3 means summation of all residues. And how we are going to find residues? For that, Rn is equal to 1 upon n minus 1 factorial d raised to n minus 1 by dz raised to n minus 1 z minus z0 raised to n f of z, z is equal to z0. If our f of z is p of z upon q of z, then this residue becomes r is equal to p of z upon d by dz of q of z, z equal to z0. Means limit z tends to z0 like that. And we are going to substitute z equal to z0 in the last step after the calculations. So here z minus function is not analytic at z equal to z0. So we have to cancel that term and remaining part we have to consider. Let us take the example. So here integration over a curve C cot z dz, where C is the circle mod z equal to 4. So my f of z is cot z, and how we write cot z? Cos z upon sin z. So denominator I take 0, sin z equal to 0. So sin is 0 for n pi, 0, pi, minus pi, z is equal to, you may take plus minus n pi, any value. N equal to 0, I get 0. N equal to 1, I get pi. So z equal to 0, pi, minus pi, 2 pi, minus 2 pi, like that. But our curve is mod z equal to 4. Mod z equal to 4. When pi we know that it is 3.14 something. So 2 pi it becomes outside the curve. And we have to concentrate only within the curve, inside the curve. Clearly. Or the boundary point or outside. By Cauchy's theorem its integral is 0, so we don't have to worry about it. Now z equal to 0, pi, minus pi lies inside the curve C. That is mod z equal to 4. So inside the circle, these 3 points are 0, 0, pi, minus pi. For the first one, suppose z1 equal to 0, I called it as z1. r1 is equal to cos z upon d by dz of sin z, using our this formula. P of z upon d by dz of q of z, z equal to z0. So cos z upon d by dz of sin z, z equal to 0. Derivative of sin z is cos z. So cos z or cos z get cancelled, we get 1. Any point, doesn't matter. For 3 points, same formula we get 1, 1, 1. And by our residue theorem, here r1 plus r2 plus r3, only 2 pi I is there. So integration over a closed curve C cot z dz is equal to 2 pi I. Integration over a closed curve C cot z dz is equal to 2 pi I. r1 plus r2 plus r3. So 1 plus 1 plus 1, we will get 6 pi I. Take one more example to understand the concept. Evaluate integral over C 4 minus 3z upon z, z minus 1, z minus 2 dz, where C is the contour, mod z is equal to 3 by 2. So one contour is there, mod z equal to 3 by 2. 3 by 2, so it is 1.5. Now take denominator z equal to 0. If I take denominator equal to 0, z equal to 0. Z equal to 1, z equal to 2. So these are the simple poles are there. Pole of order 1. Z equal to 0, z equal to 1, z equal to 2. But out of which z equal to 2 is lies outside the curve. And we are not going to find the residue for outside curve. Z equal to 2 is outside. So only z equal to 0 and z equal to 1 lies inside the curve. So we just concentrate on that 2 points only. So z equal to this 2 is lies outside. We are not going to find residue for it. Clearly, to find residues, if the question is for only to find residues instead of integration, only to find residues, then we have to find it. Otherwise, not. Okay. Now z equal to first point 0, I get R1 is equal to Z. We have to find for Z equal to 0, so Z minus 0. And this f of z as it is 4 minus 3z upon z, z minus 1, z minus 2. So this z get cancelled and put z equal to 0. We will get 4 upon minus 1 into minus 2. So 4 upon 2 it is 2. So this is our value. Second, z equal to 1. So z minus 1. So and into f of z as it is. So z minus 1 get cancelled. Put z equal to 1. 4 minus 3 it is 1 upon 1, 1 minus 1. Here 1 minus 2. So it is minus 1. So our answer is minus 1. Clearly? And R1 plus R2 into 2 pi I. So our integral over C 4 minus 3z, z minus 1, z minus 2 dz is equal to 2 pi I. Here 2 minus 1. 2 minus 1. So our answer is 2 pi I. Hope you have understood the concept of residue theorem. So this complete your complex analysis. Some more examples we will see in the next videos. Thank you.